Look at your hands for a second.
Yeah, just hold them out.
Right. The empty space between them, or the space between you and the screen or speaker you're listening to right now, it isn't empty.
Not at all.
It's not this, inert stage where things just happen. It's actually a hard, finite, and vibrant structure. And if the theory we're diving into today is right, that seemingly empty space is dictating absolutely everything around you.
Everything.
Yeah.
From why you can't push your hand through a solid wall, all the way to the real reason the Big Bang wasn't actually the beginning of anything.
Exactly. I mean, usually when science hits a problem, it acts kind of like a plumber, right? You have a water leak in an equation, or maybe a weird glitch in how a galaxy moves, and the theoretical physicist comes in with a mathematical patch.
Yeah, they fix that one specific corner of physics, pack up their tools, and leave.
Right.
And honestly, that's been the standard methodology for almost a century.
Yeah.
I mean, the standard model of particle physics, general relativity, they are absolute triumphs of pragmatism.
Sure, they work.
They work incredibly well inside their very specific bounded domains. You fix the pipe, but, and this is crucial, you are strictly forbidden from questioning the foundation of the building itself.
But today, we are not here to talk about patches.
No, we are not.
We're looking at a completely different scenario. Today, we're tackling a theory that basically walks into the building, looks at the blueprints, and says, the problem isn't the plumbing. The problem is that your entire architecture assumes things that are structurally impossible.
That's a bold claim to make.
It is. So, welcome to this deep dive. Our mission today is to completely unpack the TTN.
The nodal theory of everything.
Right, the TTN. We're basing this on a master script called TTN, the theory that accepts no patches, and we're pulling from a bunch of technical papers, plus the foundational book, the Grand Toe TTN Compendium, Volume 1 Foundations, Coherence, and Universal Validation by Miguel Jorge Diaz Luna, who also goes by Michelle.
Now, I think we need to put a massive critical warning on the table right away.
Oh, definitely. The title alone.
Yeah. Exactly. The title Theory of Everything, it carries a lot of heavy baggage in the scientific community. It breeds skepticism.
And rightly so, honestly.
Rightly so. Historically, a lot of proposals claiming that title end up being these overly permissive mathematical frameworks. They lose all of their predictive value.
Like the ones with, what, dozens of hidden dimensions?
Yes. Or all these adjustable free parameters. They become these mathematical sandboxes where if you just tweak the numbers long enough, you can make literally anything fit the data.
A TTN isn't doing that.
No. The nodal theory of everything operates at the absolute opposite extreme. It is not a permissive sandbox. It is a brutally restrictive ontological architecture.
And that's really the core thesis I want you, the listener, to keep in mind every single minute of this deep dive. When a theory has the sheer audacity to touch multiple layers of reality, from the smallest quantum scales all the way to huge galactic clusters, and it introduces strict, inflexible physical prohibitions, makes testable predictions, and its math doesn't just immediately break when you move from one branch of physics to another.
Then we are looking at something scientifically very, very serious.
Exactly. This isn't speculative philosophy. This is hard physical architecture.
Right.
So let's dismantle it from the ground up. And to do that, we actually have to unlearn the most basic concept we have. Where do things happen?
Yeah. The where is the biggest hurdle.
I mean, historically, Isaac Newton sold us on this idea of absolute space, like this grand, rigid, unchanging cosmic theater where objects just sort of existed.
And then Einstein came along, and with general relativity, he made that stage dynamic.
Right, it could bend.
Exactly. Space-time wasn't rigid anymore. It could stretch, warp, and curve under the weight of mass and energy. But, and this is where TTN steps in the relativistic revolution kind of stopped halfway, because it kept this deep conceptual hangover. Dualism.
Dualism, two separate things.
Right. In modern standard physics, we still have two distinct entities negotiating with each other. On one side, you have the geometry of space-time.
A stage.
The stage. And on the other side, you have the ontological content, the matter, the energy, quantum fields, the actors.
And they interact, but they're fundamentally different things.
Exactly. They influence each other, but they remain entirely separate categories of existence.
Okay, and this is where TTN just flips the table with its foundational axiom. What the theory calls postulate zero, structural immanence.
Yeah.
The theory claims that this dualism is a complete illusion. There is no container. There is no background space-time where particles just magically appear.
None.
Let me try to ground this with an analogy for you. Think about a digital screen, maybe the one you're looking at right now. When you see a red car moving from left to right, your brain naturally assumes there is a car traveling on top of a background.
Because that's how we experience the world.
Right. But if you take a magnifying glass to the screen, you realize there is no object actually moving. There's just a fixed grid of static pixels. The movement of the car is actually just a sequential change in the activation state of those pixels.
The car doesn't travel through the screen.
No. The car is the screen, just in a specific regime of activation.
And that analogy perfectly captures the mechanism, but TTN takes it to its ultimate physical conclusion. Structural immanence postulates that the entire universe is a single underlying nodal network. There is no outside.
So existing doesn't mean occupying a place in space.
Exactly. Existing means being an internal manifestation of the connectivity and coherence of this one network. Every physical thing, light, lead, gravity, even time itself, is simply a different regime of organization within this single fabric.
Okay, let me unpack this. If we go with this network idea, this massive interconnected mesh, what happens to what we call the vacuum? Because if I look up at the night sky, I see stars, and between them, just huge abysses of blackness. If there's no container, what is that empty space?
Well, contemporary physics treats the quantum vacuum like this boiling soup of virtual particles constantly popping in and out of existence.
Right, very chaotic.
Very. But TTN cleans all those ghostly entities out of the picture. Through the nodal lens, a vacuum isn't the absence of matter. It's just the network itself, in its resting state, what the theory calls the omega-zero regime.
Omega-zero.
Right. The structure's there, it's fully connected, but it's operating with the absolute minimum level of tension and phase variation. It's the fabric, but totally relaxed.
Okay, so if the vacuum is relaxed, what is solid matter, like the table I'm leaning on right now?
Matter is simply a region of that exact same network where a very high degree of coherence has been induced. It's an extreme concentration of information. TTN calls it structural saturation.
So it's not a new substance added to the network.
Yeah, you just nodded the network itself. Mass isn't some mysterious intrinsic property. It's literally the measure of structural tension concentrated in a nodal region.
Wow.
And that's exactly why gravity doesn't need mysterious gravitons shooting across empty space to pull objects together.
Because the network is already connected.
Exactly. A massive node is so tense that it creates a phase gradient around it. It forces the adjacent network to curve its metric just to minimize the accumulated contradiction. Gravity is just the network trying to balance its own internal tension.
Okay, so if the whole universe is built on this single network architecture and mass is just accumulated tension, that has to impose some draconian limits.
Oh, absolutely.
Because you can't stretch a real physical material to infinity, and you can't compress it forever without it breaking or changing state. And this brings us to one of the most aggressive parts of TTN, the power of its prohibitions.
Yes.
Because traditional physics is just riddled with mathematical infinities that honestly have always felt like a bit of an embarrassment.
Physicists usually call them pathologies. I mean, when the math of general relativity predicts the center of a black hole, it gives us a singularity, a point in space with exactly zero volume and infinite density.
Which makes no sense.
Right. Or when quantum field theory tries to calculate how electrons interact at infinitely small distances, the equations just blow up to infinity. So theorists have to use these complex processes like renormalization, which is basically just subtracting one infinity from another infinity, so you're left with a number that matches the lab experiments.
It's totally like sweeping mathematical dust under the rug.
It really is.
But TTN refuses to do that. It explicitly forbids physical infinities. It forbids an absolute vacuum. And it forbids action at a distance without some kind of structural mediation.
And the reason for these prohibitions is baked right into immanence. If the network is all there is, that network cannot be an infinitely divisible continuum. It has to have a limit scale.
A minimum resolution.
Yes, formally denoted as the TTN length, or LTTN. You cannot have a node smaller than that, and you cannot cram an infinite amount of information or tension into a single vertex of the network. Any theory that demands an infinite value is violating the structural capacity of reality. Therefore, it's ontologically false.
Okay, hold on. Let me push back here for a second. If we are flat out prohibiting infinities and singularities, how do we explain the big monsters of astrophysics?
You mean black holes?
Black holes, the Big Bang. If a massive star collapses under its own weight and doesn't form an infinitely dense point, what is actually inside a black hole? And what about the Big Bang? If there was no infinitely dense singularity that exploded, how did all this start? It's hard to imagine a universe that just stops before reaching infinity.
The mechanism that stops it is called nodal saturation.
Okay.
Think about a computer hard drive. If you try to save 1,000 terabytes of data onto a 500 gigabyte drive, the drive doesn't compress down to infinite density, right?
It just crashes. Or says disk full.
Exactly. It hits its physical write limit and rejects new data, or the OS forces a structural collapse of the process. In TTN, the network has an absolute capacity limit dictated by the Diaz Luna constant. So when the matter of a collapsing star tries to tend toward infinite density, it literally hits the saturation wall of the network.
So the physical fabric of the universe just says, nope, no more room.
Exactly. And faced with that blockage, the network has to reorganize itself. So the core of a black hole in TTN isn't some mathematical anomaly with zero volume. It is a wildly dense but entirely regular and finite structural knot. It's matter in a state of absolute saturation.
That is fascinating.
And for the Big Bang, it's the exact same principle,
Yep.
just scaled up globally. The pre-expansion universe wasn't some magical infinitesimal point floating in nothingness.
Right.
It was the entire nodal network sitting in the state of critical phase saturation, maximum tension. Once it crossed that limit threshold, the network underwent a massive reorganization event. It transitioned from that latent hyperdense state into a rhythmic geometric expansion just to release and redistribute all that tension.
So the infinity just vanishes, and we get robust structural mechanics instead.
Precisely.
That completely rewrites the cosmological playbook. But I want to take this structural magnifying glass and swing it all the way to the other extreme, down to the tiny stuff.
The quantum scale.
Right, because standard physics has been stuck in this almost mystical crisis of weirdness for a century there. I'm talking about quantum mechanics and the famous double-slit experiment.
Oh, yes. The wave-particle duality.
Right. We're all taught that a particle like an electron is just this wave of probability spread out across space when no one is looking. It supposedly goes through two slits at the same time, interferes with itself, and then the exact millisecond you decide to measure it, the wave magically collapses and the electron decides to exist in one specific spot.
Yeah, that's the Copenhagen interpretation. It assumes the particle exists in this abstract mathematical superposition in Hilbert space until the act of observation literally forces material reality to happen.
Which sounds crazy.
It's deeply unsatisfying. It turns the act of measuring into this almost supernatural event that creates geometric reality. But TTN dismantles that mysticism completely by introducing a revolutionary concept, the Vox state.
Okay, this is where a lot of people might get lost. Explain the Vox state to me like I've never heard the term before. If the particle isn't spread out through space like a ripple in a pond, where is it exactly?
Well, the limitation of the classic model is assuming that everything has to happen inside the 3D spatial regime that we humans perceive. TTN breaks quantum existence down into an ontological triad. You have the Vox state, the wave, and the particle.
The triad, Vox, wave, particle.
Right. The Vox state is the pre-spatial regime. When an electron isn't interacting heavily with its environment, its phase information doesn't localize in one single node, but it also doesn't smear out like a physical bedsheet.
Okay.
Instead, it gets distributed as a purely nodal configuration across subnetworks. It doesn't have geometry in that state. It only has connectivity.
Oh, I see. So going back to the screen metaphor, it's like the data for the red car is being processed inside the microchip, flowing through the graphics card's circuits, but it hasn't sent the command to light up specific pixels on the glass yet. The data is there, it's getting processed, but it hasn't projected into visible space.
That is an excellent parallel. That quantum multiplicity, this whole idea that a particle is in multiple places at once, is an illusion caused by us forcing spatial concepts onto nodal processes.
So it's not actually in two places.
No. In TTN, there is no spatial multiplicity. There is only structural multiplicity. The network is keeping multiple permitted coherence channels open, processing the phase evolution underneath.
And what about the wave and particle parts?
Right, so the second element of the triad is the wave. That's a propagation regime where this phase information starts to collectively oscillate across the nodes. And the third regime, the particle, is the purely localized event.
Wait, so if the collapse of the wave function isn't caused by the conscious mind of a physicist in a lab coat looking at a screen, what physically is a measurement in TTN?
In TTN, measuring something simply means injecting a massive gradient of coherence into the system. A measuring device isn't magic. It's a macroscopic arrangement of trillions of nodes in a highly saturated structural state.
It's just a really dense knot.
Exactly. And when that mountain of macroscopic information interacts with the fragile distributed Vox state of an electron, the underlying network is subjected to a massive pressure differential. To resolve that instability, the network forces a structural phase transition.
Oh, wow.
The distributed information crosses a critical threshold and localizes into a single effective node, manifesting geometrically. The collapse isn't magic, it's just nodal thermodynamics. It's like water freezing into ice when the temperature drops, a state change dictated by environmental tension.
Okay, so if we've redefined a particle as just a localized knot of tension, what happens when the math demands negative values? I mean, historically, Paul Dirac's equations predicted electrons with negative charge, but they also hinted at negative energy states.
Yeah.
And for almost 100 years, the standard physics solution was to just invent a totally separate category of existence, antimatter.
Yes.
We treat positrons or antiprotons like they are this exotic mere substance that, if it ever touches normal matter, destroys both in this massive annihilating explosion.
And that concept of ontological annihilation clashes completely with TTN. Remember, immanence forbids a piece of the network from just ceasing to exist.
Right. You can't just delete a node.
Exactly. So under this theory, antimatter is not a different substance from a mirror universe. It is the exact same structural node in the network, but it's operating with an inverted topological index.
An inverted index.
Yes. They have a diametrically opposed structural phase, which TTN formalizes as an S value equal to -1.
We really need to visualize this physically. Imagine I'm holding a thick rubber band. If matter, let's say an electron, is a rightward twist in this rubber band, creating a little topological knot that builds up tension,
Okay.
then the positron, the antimatter, isn't a different rubber band from another dimension. It's the exact same rubber band, but deliberately twisted to the left.
Yes, exactly. That topological defect analogy is the perfect geometric translation. Spin or electrical charge aren't these little intrinsic properties glued onto a particle. They are torsional configurations in the nodal mesh.
So what actually happens during the famous annihilation event, when the electron and positron hit each other?
Well, think of your rubber band. If you push the right-hand twist and the left-hand twist together on the same band, what happens? The twists mutually cancel out, the band violently untangles, and it releases all that stored elastic energy as tension.
And that's why we see a flash of gamma rays, high-energy photons exploding out of the collision.
That's the mechanism. TTN calls it a recoherence event. The nodal network didn't destroy anything. It merely redistributed the phase tension. The opposing polarities topologically cancel each other out, and the energy stabilizes by transitioning into a pure photonic mode, returning to the underlying Vox state. The information is never lost. It just radically changes its vibrational regime.
You know, here's where it gets really interesting. This inevitably brings us back to a fascinating historical debate. Yes, Albert Einstein famously hated the direction quantum mechanics took with all its blind randomness. His legendary quote, "God does not play dice with the universe," really summed up his frustration with the idea that nature is fundamentally probabilistic. And almost poetically, the nodal theory of everything resurrects Einstein's stance and gives him the math to back it up.
It does, because the standard model asks us to accept ontological randomness. It claims that before a measurement, the universe literally hasn't decided the outcome. There is no definite underlying reality. PTN refutes that entirely with its principle of geometric determinism.
Okay, so the quantum randomness we see in labs
Is not the universe rolling dice. It is pure and simple epistemological ignorance on our part.
Wait, epistemological ignorance, meaning we just don't have enough data? It's not that the event lacks a cause.
Exactly. If you had access to the complete coherence map and the phase gradients of every single individual node involved in an interaction, the evolution of the system would be mechanically deterministic.
We just can't see the gears turning.
Right. We perceive probability because our macroscopic tools can only interact with statistical average projections of that network. We can't see the individual granularity of each pre-spatial node. Einstein intuited that a layer of reality was missing. TTN defines that missing layer as the dynamics of the immanent network.
That sounds beautiful in principle.
Yeah.
But saying the universe is strictly deterministic at the nodal level, that's going to infuriate a huge chunk of the theoretical community today.
Oh, without a doubt.
Especially the folks deeply invested in the many worlds interpretation or string theory. If probability is just our ignorance, what does TTN do with the multiverse? I mean, the idea that every time a quantum particle faces two paths, the entire universe splits, creating infinite parallel realities.
TTN aggressively attacks the concept of the multiverse. Architecturally, the theory considers it an aberration and, frankly, mathematical cowardice.
Wow.
TTN establishes an absolute prohibition of ontological multiplicity. If we start from postulate 0, where only this singular immanent network exists, the idea of instantaneously duplicating all the mass and structure of the cosmos trillions of times a second just to resolve a local quantum uncertainty is physically and thermodynamically unjustifiable.
It's like if my accountant couldn't find a $10 discrepancy in my company's books, so they just legally created 2 million shell companies, so the overall statistics eventually made sense.
That's exactly what it is. It's an evasion of the measurement problem.
Right.
The multiverse externalizes its problems into unobservable dimensions by design.
Right.
TTN forces physics to solve the problem here and now. The universe doesn't split, it selects channels. During an interaction, the network evaluates the phase gradients and curves its topology toward the configuration with the minimum accumulated contradiction. One result manifests and the other channels simply dissipate at the nodal level. This anchors the theory firmly in the empirical reality of one single verifiable universe.
All right, so we've rebuilt space, matter, the vacuum. We've torn down the multiverse and kept a single deterministic network. But we left out the slipperiest dimension in all of physics, time.
Time.
If we don't have a spatial container anymore, how does the network experience the passage of time? Because even with Einstein, even though time is flexible and weaves into space, it's still treated as a geometric dimension that we travel through. Like the universe has a master clock, or at least a continuous space-time fabric.
That geometric conception of time is another casualty of the nodal paradigm shift. TTN dismantles the idea that time is a continuous background or a navigable fourth dimension.
So what is it?
In the nodal architecture, time is strictly an emergent structural property.
Right.
It doesn't flow independently of matter. It is generated by matter and the network. It's defined as the update rate of the internal states of the nodes.
Like processing speed?
Exactly. Think of discrete pulses, literal computational ticks in the structural network. Time only exists because nodes are reconfiguring their phase and exchanging information with their neighbors.
Wait, really? Let's take that to its logical extreme. If time equals the update rate, the ticks of the nodes, what happens in a system where absolutely nothing changes? If a region of the network enters total stasis, zero information exchange, does time literally stop existing for that region?
Structurally, yes. Local time stops. And this isn't just a philosophical trick, it actually offers a mechanical explanation for extreme phenomena. Let's look at the event horizon of a massive black hole again.
Okay.
Relativity predicts that, to an outside observer, time seems to freeze at the horizon. TTN explains why. The structural saturation at that boundary is so massive, the information density is so suffocating, that the nodes exhaust their processing capacity.
They max out.
They max out. The phase update rate becomes asymptotic to zero. The local clock doesn't tick because the nodal processor is completely locked up, just managing the extreme tension of the gravitational knot.
Oh, man. So if time runs on discrete processing ticks, how does that fit with the second law of thermodynamics and entropy? I mean, high school physics tells us entropy is the measure of disorder, and it always increases, giving us the arrow of time. That's why a dropped egg shatters, but the pieces never magically jump back into your hand.
Right. The traditional view treats entropy as this statistical degradation into heat. But TTN reinterprets entropy at a fundamental level as a discrete signature, specifically as the shot noise associated with the discrete temporal activation sequences of the nodes.
Shot noise.
Because the phase transitions between nodes happen in jumps, they generate an intrinsic structural noise, an irreducible informational friction in the network.
And just so we don't lose anyone in the jargon, the source papers frequently mention the Fano factor when talking about this temporal noise. For those of us without PhDs in quantum statistics, what are we actually measuring there and why does it matter?
The Fano factor is basically a mathematical way to measure the variability of a process. If events like photons arriving or currents pulsing are completely independent and random, they have a Fano factor of 1. If they're highly correlated or bunched together, the factor changes.
Got it.
By predicting that entropy emerges as discrete shot noise during nodal updates, TTN predicts specific deviations in the Fano factor at the subatomic level that would make zero sense if time were a smooth, continuous flow. It literally measures the granularity of the universe's clock.
Wow. And what about the arrow of time?
The arrow of time doesn't exist a priori in isolated microscopic interactions. At the level of just two interacting nodes, the process is perfectly reversible.
So where does our past and future come from if there's no direction down there?
From collective coherence. The macroscopic arrow of time emerges when a gigantic number of nodes interact massively.
Oh, like a crowd.
Exactly. Imagine one person wandering around an empty stadium field. Their steps don't show an obvious directional flow. But put 80,000 people in that stadium and set off the fire alarm. The interaction of the crowd creates a massive, irreversible flow toward the exits.
Okay, that makes perfect sense.
Similarly, when the nodal system reaches macroscopic complexity, the statistical noise forces the network to evolve toward states of tension relaxation. The past is simply the unalterable record of nodal updates that have already consolidated, and the future is the stochastic regime of phases that haven't resolved yet.
If time and entropy are really just the footprint of the network processing information, that means our entire cosmos is basically a giant structural computer.
Yes, in a sense.
And in any good computer system, there are hidden files, compressed partitions that take up space on the hard drive, but you don't see them on the desktop. Under the TTN lens, is this what astrophysicists have been calling dark matter for decades?
It's actually one of the most elegant applications of structural immanence. The dark matter problem has haunted astronomy for decades. We look at galaxies spinning so fast that if they only contain the mass of the stars we can see, they should fly apart.
Right, the visible gravity isn't enough to hold them together?
Exactly. So standard physics introduced the lambda CDM model, assuming there must be a colossal halo of cold dark matter, massive particles that barely interact with anything, like the famous WIMPs. But we've poured billions of dollars into particle accelerators and underground detectors, and we haven't found a single WIMP.
Because according to TTN, we're looking for a magical particle when we should be looking at the structure of the fabric itself.
Precisely.
I love the ZIP file analogy from the source text. Let's dig into that. If the universe is the hard drive, dark matter isn't some exotic new invisible hardware someone secretly installed. It's just data. It's a massive amount of compressed, encrypted files, a ZIP file. It takes up space on the drive, so it has a huge structural weight or pressure.
Which we perceive as the gravitational pull holding galaxies together.
Right, but because it's compressed, because its electromagnetic phase channels aren't active, your monitor's software can't read it. It doesn't emit light.
The analogy is formally flawless.
Yeah.
Mathematically, TTN doesn't need to invent a ghost particle. It formalizes dark matter as the net difference between the total quantum information housed by a nodal cluster and the portion of that information that is actually coupled to the electromagnetic spectrum.
So it's just decoupled.
Yes. They are nodal domains trapped in decoupled phase cycles. The theory calls this the ZIP mode. They have immense intrinsic structural tension which curves space and provides the gravitational scaffolding for galaxies, but they are completely invisible to our telescopes because they simply don't emit or absorb photons. It is pure network physics.
But if dark matter is the ZIP file, what do we do with the other dark sibling? Dark energy. We observe empirically that the universe isn't just expanding, it's accelerating. Galaxies are flying apart faster and faster. The standard model throws in this mysterious repulsive force from the quantum vacuum to explain it. But the theoretical calculation for dark energy compared to what we actually observe is off by over 120 orders of magnitude. It's arguably the worst miscalculation in the history of physics.
That abysmal error is proof that the let's just add a new substance approach has hit a dead end. TTN doesn't treat the accelerated expansion as a mysterious outward force. It treats it as the thermodynamic byproduct of nodal evolution. If dark matter is the static ZIP file, dark energy is the processor, the structural CPU of the universe working overtime to compute, update, and decompress the massive archive of information it holds.
Wait, so the universe is expanding because it's computationally heating up?
In terms of nodal dynamics, the network has what's called hysteresis, like a structural elastic memory.
Okay.
The continuous reorganization of the mesh constantly processing Vox states into matter and back again generates a massive flow of activity. On a cosmological scale, the sheer dominance of this update flow creates an effective negative nodal pressure.
I see.
This expansive tension is exactly what our observatories are measuring as cosmic acceleration. Dark energy isn't pushing from the outside. It is the network itself stretching to accommodate the growing processing load of its own information.
All right, up to this point, we have built an impeccable conceptual cathedral. We've swept away a century of mysteries and replaced them with a hard, logical information ecosystem.
Yes, we have.
But I want to play devil's advocate for the skeptical physicists listening, the ones who need to see the equations. History is full of beautiful philosophies that totally fall apart when you hit the chalkboard. So don't just tell me TTN uses variables. What is the actual mathematical engine that lets you calculate this nodal pressure and coherence without inventing weird extra dimensions?
The rigor of TTN is cemented in its main analytical apparatus, the Figge microcontinuum model. And this isn't just decorative math. It's a dense differential framework designed to map a discrete immanent system using analytical state variables.
Phi and K.
Right. The theory introduces two conjugated scalar fields. The first is phi, which quantifies the intrinsic coherence and phase of the nodal domain. It's the measure of local order.
If phi is the order, what is K? When we say nodal tension, is it like the surface tension of water in a droplet, fighting to keep the liquid together against disturbances?
That is exactly the right intuition, just applied to the ontology of the vacuum. K is the field of nodal pressure, or background structural tension. It measures the network's resistance to being deformed.
Okay.
We saw similar order parameters in the Ginzburg-Landau model for superconductors, but TTN scales it up to universal gravity. The master equation of state establishes that the effective deformation of spacetime, the metric we actually feel, is governed by a structural invariant called S, and S is just the multiplicative coupling of those two fields. S equals phi times K.
So you multiply the internal order by the network's surface tension, and that product tells you how curved or massive that region of the universe is.
Exactly. But the fake model has a vital internal safeguard, governed by that fundamental quantity we mentioned, the Diaz Luna constant.
Right, the capacity limit.
Yes.
Yeah.
In the equations, this constant acts as an inexorable stabilizing attractor. It mathematically guarantees that the network cannot explode into infinite divergence like we saw with avoiding black hole singularities.
It stops the math from breaking.
And it also prevents it from falling into total disconnection, or an absolute mathematical zero. It forces the system to maintain permanent background connectivity. It is the hard analytical guarantee of structural immanence.
And this math isn't just floating around in astrophysical abstractions billions of light years away, right? My understanding is that this same Fick model is actively being tested on condensed matter physics right here on Earth.
And that is arguably its strongest selling point. A theory of everything can't just work for the Big Bang, it has to work on a lab bench. The TTN nodal equations have provided incredible analytical corrections for quantum fluids, specifically for the dynamics of type II vortices inside superconducting regimes.
Oh, wow.
By mapping phase defects in the microcontinuum, TTN provides a precise boundary criterion for the transitions between macroscopic and mesoscopic phases in a liquid helium cryostat. The exact same math governing gravity is regulating a superconducting circuit under a microscope.
Which opens the door to the final hurdle: empirical validation, real-world proof. Theories like this get hammered because they require immense evidence. And people usually want a silver bullet experiment, right? Like when Eddington's expedition observed the 1919 solar eclipse and proved Einstein's curved space in one fell swoop.
Yeah, everybody wants an Eddington moment.
Does TTN have its own silver bullet?
Demanding a single silver bullet for a holistic architecture like TTN really misunderstands how network science works. Validation doesn't come from one miraculous flash. It comes from a dense accumulation of cross-validations.
So hitting it from multiple angles.
Exactly. The core argument is probabilistic and structural. When you find footprints of the discrete network in astrophysics, in galactic cosmology, and in quantum crystallography all at the same time, mathematical coincidence becomes statistically impossible.
Okay, let's break down some of those footprints because the sources detail some fascinating ones. Let's start with what they call the 1M law in gravitational wave dispersion. Just for context, standard physics says a gravitational wave is a smooth ripple in spacetime caused by something like black holes colliding that travels at the speed of light regardless of its frequency. What does TTN predict differently?
In TTN, a gravitational wave doesn't travel through a perfectly smooth continuum. It travels by propagating phase gradients across a discrete structural mesh of nodes.
The grid.
Right. And here's basic wave physics. If you send a very low frequency wave, very long wavelength across a fine grid, the wave doesn't feel the bumps. It flows like the ground is smooth.
Makes sense.
But if the wave is extremely high frequency, its wavelength is so microscopic that it starts to interact with the individual bumps of the discrete structure.
Like riding a skateboard with tiny wheels over cobblestones versus driving a massive tractor over them. The tractor feels nothing, the skateboard rattles.
That's a great analogy. And what happens when the wave hits those nodal cobblestones? It causes observable dispersion. TTN mathematically predicts an effective violation of Lorentz invariance at very high frequencies.
The wave gets distorted.
Yes. The signal perturbation follows an inverse relationship with the equivalent mass of the system, creating that 1m asymptotic scaling law. And the critical part here is that meta-analyses of signal profiles from the LIGO and Virgo interferometers looking for anomalies in compact collisions are showing high phase fluctuations that match the predictions of this granular network disturbingly well.
That covers the fast gravitational scale. What about those slow, massive galaxies we talked about? We discussed the ZIP file concept, but how do we actually prove that network dynamics can completely replace dark matter to explain why galaxies spin so fast without flying apart?
We prove it by feeding the nodal equations into massive astronomical databases, like SPARC. We're talking about the radial acceleration relation, or IRR. TTN theorists took the visible density profiles of hundreds of rotating galaxies and plugged them into the thin nodal pressure equations.
Without adding any invisible dark matter particles.
Without a single exotic particle.
Mm.
And the emergent nodal potential induced by the network geometry we talked about is enough to model the observed rotation curves with astonishing precision and minimal variance.
But the math just works.
It just works. The dynamics don't require weird particulate matter. It's purely a thermodynamic balancing act between the galaxy's connectivity and the exterior network.
And to really cap off the astrophysics side, we have to talk about anomalous gravitational lensing. This has always been the ultimate trump card for conventional dark matter defenders. They point telescopes at distant galaxy clusters and see the background light bending drastically around large patches of space where there are no visible galaxies, just some diffuse gas.
Right.
The Lambda CDM model says, aha, that's an invisible bag of dark matter bending the space after a collision. Famous clusters like CL0024 plus 17 or Abel 520 at the train wreck cluster.
Yeah, but the classic simulations of those invisible cloud collisions have had to invent these ad hoc viscosity assumptions that border on the absurd.
So how does the nodal perspective clean that up?
Those huge gravitational lenses hovering in empty space after a galactic collision aren't ghostly bags of WIMPs. They are pure scars in the network.
Scars?
Yes, it's the structural persistence of extremely high nodal coherence. The tension that accumulated in the Fouquet geometry during the collision decays much, much slower than the dynamics of the visible gas. You aren't seeing invisible matter. You are literally looking at residual structural curvature, the pure tension of the fabric itself slowly untangling.
That is just staggering. If this logical, mathematical, and observational scaffolding is really that robust, we have to talk about the sociological side of modern physics. We know how academia works. People are fiercely territorial about the established models they've built their entire careers on. What is the actual status of TTN in the scientific ecosystem right now? Is this just some underground manifesto, or is it actually fighting in the trenches of peer review?
Oh, TTN is a completely living, enormously active scientific program today. We are not talking about some isolated intellectual blog post.
That's important to clarify.
It's very important. The entire core formulation, the structural eminence postulate, the Fick model resolution, the gravitational scaling predictions, the superconductivity impacts, all of it. It's formalized in multiple technical manuscripts, and many of them are currently grinding through the hard editorial review circuit.
So it's in the hands of the journals?
Yes. There are papers marked as decision pending, sitting with editors and blind reviewers in Q1 theoretical physics and applied mathematics journals. Preprints are circulating openly, directly challenging specialists to find structural flaws in the logic. It's being actively debated and empirically evaluated.
But I have to imagine the resistance is fierce. Not necessarily because of immediate math errors, but just because of the sheer philosophical discomfort it causes. To a hyper-specialized academic world, the idea of total unification probably feels almost offensive.
It feels like a threat to their daily methodology. The great tragedy of contemporary physics is hyper-compartmentalization. You have a world expert in scalar field cosmology who hasn't spoken professionally with an expert in condensed matter superconducting crystals in 20 years. They use totally separate languages. They assume completely separate ontologies.
They're building their own little floor of the skyscraper and ignoring the foundation.
Exactly. And TTN comes along and just demolishes those partition walls. It strips away their comfortable dualism. It rips out the mathematical crutches of infinity and the multiverse. And it demands that they apply the exact same thermodynamic and structural laws to a black hole collision as they do to wave-particle duality on a lab bench. Unification always hurts because it forces people to abandon centuries of entrenched mental habits.
Oh, and I think it's vital we make this clear. TTN isn't throwing this out there with dogmatic arrogance. It's not some scientific cult claiming that 100% of the universe has been definitively decrypted in Diaz Luna's master book, and there's nothing left to do.
Oh, absolutely not. Demanding blind belief would be anti-scientific. The architects of TTN present the framework as an open, empirically iterative platform. It actually requires a massive intergenerational collective effort to calibrate all these nodal tension parameters across different subsystems.
It's just getting started.
Right. What it vehemently demands is simply a fair hearing, a theory that connects such wildly disparate domains without using magic, without outsourcing chaos to unobservable multiverses, and that predicts verifiable signatures in both earthly labs and space satellites. It simply cannot be dismissed out of hand just because it's painfully innovative.
Yeah.
We're looking at a massive paradigm shift that could genuinely be the ultimate structural revolution of modern physics.
Well, this has been an absolute gauntlet. We've basically rebuilt the universe from the rubble of patched-up theories. It's time to pull all of this together. We tore down the historical spatial stage and revealed the immense 3D screen of the imminent nodal network.
Oh, it did?
We banished the embarrassing infinities of black holes and the Big Bang, replacing them with rigid thermodynamic limits of structural saturation. We cleared up the esoteric magic of Schrodinger's cat using the Vox state and distributed nodal multiplicity.
We reconciled matter and antimatter with a simple mathematical rubber band twist.
We gave Einstein his posthumous victory over blind chance by bringing back geometric determinism. We tossed out the cosmological fraud of the multiverse. And to top it all off, we turned the invisible ghosts of dark matter and dark energy into tangible informational pressures, ZIP files, and the roaring processing tension of a network constantly evolving, ticking away time with discrete nodal updates.
All of it underpinned by the analytical variables of a microcontinuum that you can actually measure in a frozen crystal here on Earth.
It is a staggering synthesis, and yet it barely scratches the surface of the profound implications detailed in the theory's foundational compendium. We have literally touched on the structure of existence itself today. And it's right there on the structure of existence that I want to leave you with one final provocative thought. Something powerful for you to chew on when this audio ends and it gets quiet. For the past hour, we've talked about cosmic entities, distant stars, the Big Bang, the invisible fabric of the vacuum. It's really easy to isolate these concepts as if they're just cold documentary facts happening out there.
Yeah, as if we're separate from it.
Exactly. But think about this coldly for just 1 second. If the nodal theory of everything and its postulate of immanence are correct, you are not a visitor in some universal theater. You are not some biological blob clumsily pushing your way through an alien empty space.
Bad at all.
You are a knot. You are an immensely complex, hyperdense, beautifully saturated local architecture of information, woven directly out of the exact same immanent material as the universe itself. Your thoughts, your heartbeat, the warmth of your skin. All of that is nothing more than the structural network of the cosmos vibrating, reconfiguring, and processing nodal phase at every single millisecond of your existence. You aren't contained in the universe. You are the universe, temporarily organizing itself under the label of your name.
That is a profound realization.
So I'll leave you with this question. Knowing that you and the seemingly empty air right in front of your eyes are threads of the exact same unbreakable fabric, how is that going to change your perspective tonight? When you tilt your head back, look up at the dark sky, and realize that the black abyss between the stars is just as alive and just as tense as the blood in your veins.
It has been a deep intellectual privilege dissecting this structural architecture with you today.
And a massive thank you to you for giving us your time, your attention, and your curiosity on this monumental journey through the bedrock of reality. Keep that incisive gaze sharp. We'll see you on the next deep dive.